let's get started with the October 2021 OpenZFS Leadership Meeting, the last leadership meeting before the Developer Summit Conference. Looks like we have a couple of items on the agenda. Powell, if you're ready, why don't you take it away? I'd love to hear an update on the block reference table stuff.
Okay, sure. I hope you guys hear me well.
Yeah.
So it's been a year since I presented the idea, actually almost exactly a year. And a sense of guilt, I guess, dragged me back to this project because Matt and George spent a lot of time with me explaining some stuff, and so I didn't want to all this go in vain. I'm really happy that I recorded our session, and I could go back to the project. So the progress I made is that block reference table works. ZFS write override trick works for this purpose. So currently the way it works is that for now the data structure is pretty much similar to the duplication. So this is something that have to be worked on. I guess we want a more optimal data structure. But when we clone a file, I create a kind of log in memory that keeps tracks the references I add to the given block and transaction group it is happening in. So in open context, basically I just gather all the changes that are happening to the blocks in terms of cloning. And then in the syncing context, I apply those incremental references, and when we handle freeze, we will decrease the references and sync entries to disk. So we don't need additional step in the ZIO pipeline for writes. We do need additional step in ZIO pipeline for freeze. So this is how it currently works. I have a demo to show, but there are still some few remaining issues and some few interesting observations. For example, it does work with the duplication, so you can use both. There is one issue remaining with that. It works with embedded blocks. It doesn't work with holes yet. I get a panic. I'm not sure I understand how holes are created. I don't think we create a dedicated block pointer when we have a hole. I think it's handled in the parent block, but I didn't check that yet. But when I just copy block pointer to the new file, I get some panic somewhere. So I need to investigate that further. Let me take a look into my notes. So the whole interaction with the duplication is pretty interesting. So if we have a block that was cloned using block reference table, and also we have the same block was have additional reference in the duplication table, so we have additional references in both tables, we actually can decide what to do because it will act differently if BRT3 is before DDT3 or the order is reversed. So for example, if we are happy with the duplication implementation and basically we don't want to get rid of the duplication table, we would like to have BRT before in front of DDT3. So we want to keep the duplication references in the table, so regular writes can bump those references. But you can also use BRT to, let's say, hijack or replace the duplication. So if we put the duplication in front of BRT, we can simply clone a block So we will create reference in the BRT table. And then when we free the block, it will be free in the duplication table. So we can decrease the duplication table this way by cloning blocks, and we will keep the references in the BRT table and when we free, we get rid of reference in the deduplication table. So once the duplication table have no more references, we'll fall back to BRT and start freeing BRT references. So I don't know, just observation. Also, in terms of interaction with the duplication, I was wondering how we can address, because not sure if you remember, but BRT is not sendable. We cannot send information to the remote host that this block has additional references, because it simply the block pointer is totally different. But we could send a hint to the remote server that this block has additional references, and the remote server could put this block onto deduplication table. So when we, so this is just a hint. There might be not additional copy in the remote server of this block, but let's say there are higher chances that this block is the duplicatable, let's say. So we could use like the duplication on demand on the remote server, something like that. So that's the only idea I came up with to address sending for now, how to, because BRT and deduplication, of course, is very similar to some extent, but also very different.
Yeah, could you remind me, like, with the, how's the BRT working? I remember it's like you're basically cloning files, and then like there's some table that keeps track of like these files all share some blocks with a ref count, but can you remind me, like, what that is that table specific to the file, or is it to the file system, or how does that work?
So the BRT table is global, just like the duplication table.
Okay.
So we are not cloning files per se, we are cloning blocks.
Okay.
So so internally, we could clone any block. So we can go to a file, locate a block, and just clone this block into the same file, into different file, into different data set. Because the table is global, so we can, so simply we just copy block pointer to the new file, and just update physical and logical birth times of the blocks.
And the table, is the block reference table kind of like the dedupe table maps from the hash value to the location on disk in the ref count. What's the mapping in the block reference table? Is it the same or is it different?
It's different. It's much smaller. In a block reference table, the key is VDEF ID and offset. Just a single VDEF ID and offset, because it will be the same in every block pointer that we clone. And the data is only ref count. So that's it. And also, when the block is not cloned, there is no entry in the
BRT if the ref table count is 1, then there's no entry, essentially. Yeah.
Yes. So to remind, if you don't use BRT, there is no cost. But there is a cost once you start using BRT. There is a cost on every free. Okay. Because there is no special flag in the block pointer, so we have to consult BRT table for freeze. So
if I kind of compare this with dedupe, you could use dedupe to do the same thing. Like, you know, like presumably you have some higher level operation that's like, hey, like I want to copy this file, but make it fast, right? And you could do the same, or like I want to copy this part of this file into this other file or whatever. And you could do the same kind of thing using dedupe, just like, you know, you go find all the block pointers, you add the block pointers over here, you bump up the ref count in the dedupe table. The downsides, or like the advantage of the block reference table is basically like all the kind of critical operations are all kind of O of the same thing. They have to look up in this potentially giant table, but the entry size in the table is smaller, and you never have entries for things with ref count 1, which could potentially be huge.
Correct.
I see. So it's like, it really is kind of like better dedupe when you know what you're deduplicating, like application driven dedupe, where the application is telling you, like,
It's like on demand.
these two things are going to be the same, so dedupe them. But of course, there's copy on write. So if you write to one, then you get that one has its own copy like normal.
Exactly.
That's okay.
Exactly.
Yeah, I think the big benefit that you talked about, Paul, was for example, copying a file from a snapshot back to the host file system to revert a change or whatever, is now you're referencing the already on disk version, and so A, it's faster, and B, it doesn't use any space compared to now, if you're reverting one file from a snapshot, you're actually rewriting that whole file.
Yeah,
Yes.
and you aren't having to you're creating entries in this new table, but you don't like have to. You could do a similar kind of thing with dedupe, but you would have had to like turn on dedupe already,
right,
and pay the cost of having those blocks be in the dedupe table the whole time.
And you have to read the data before writing them back.
You don't really. I mean, you wouldn't really have to do that.
You could bypass that. That's true. You could.
I mean,
I did that once a long time ago. That you could just read block pointers.
yeah. I mean, that's what you're doing for your use case, right? Like you have some ioctl that's like, hey, like copy this file, and you're going and reading all the block pointers and then adding them to a table.
Correct.
So you could do the same kind of thing with dedupe if you had dedupe enabled.
Yeah.
But with the new syscall copy file range that's in BSD, and I think this in Linux as well, meaning that copying files between ZFS datasets wouldn't have to, or moving a file between two ZFS datasets could be reference and
by
just
reference.
on all metadata operation, basically, instead of actually having to copy the entire file, would speed things up and just make ZFS feel a lot nicer too.
That is
at the
true.
cost of the freeze having to go to this giant table.
Yeah, unfortunately. But also internally, as I said, I'm cloning blocks, but the interface I came out with for now is clone file system call, that I basically clone the entire file. The reason for that is that it's if you copy file range, you operate on offsets, and here you cannot really operate on offsets. You would need to you could integrate that with like copy tool or something like that to figure out where the block boundaries lie, and basically just copy the data when you cannot copy the whole block, and just copy the data when it's part of the block.
I mean, I suspect that practically speaking, copying whole files is 99.99% of the use case.
That was my thinking. Yes, exactly.
Yeah, it was just 2 weeks ago or so. I was wondering if you got anywhere with this, because at EuroBSDCon in the social section, we were talking about trying to do some kind of like UnionFS thing in ZFS. And the most complicated part was when you have a second ZFS file system mounted over top of a first one, and you modify a file, you have to basically copy up the entire file to the new file system, to the top file system. But really in ZFS, you'd want that to be like a clone, not a full copy. But if your thing works, then we would literally basically copy up the whole file and overwrite the one bit that we're changing or whatever. And that would make this work really nicely.
Yes, definitely. Let me take a look at my notes.
You mentioned like better data structures. Were you thinking something like having the same kind of basic idea of mapping from DVA to ref count, but like being able to do like runs of DVAs or something, where it's like, well, if the file happened to be all contiguous on disk, then we could be like, oh, like it's this whole range, this whole like gigabyte of the disk has ref count 2 because I copied the file and the file was all contiguous in this 1 gigabyte. Is that the sort of thing you're thinking about, or was it something else?
So I'm most concerned with the cost on every free. So I wonder. So we need some kind of data structure that can tell us that the block is not there quickly.
Okay.
To not penalize regular frees. And
right.
So I don't
So
really.
like a Bloom filter or something.
So yeah.
Right. A Bloom filter could tell you if a block is maybe in the table, with the cost of like roughly 10 bits per 10 bits of, like if you wanted to have this in memory, 10 bits per block.
Mm-hmm. Yeah, so maybe something like that. But at the end, we may need to limit the size of BRT, just like you were thinking about changing data structure for deduplication to also fit into memory. If we are going to do that, make the table to fit into memory, then then we would probably want to have additional system call when we are moving files between data sets, because this is also interesting operation when we just want to move a file between data sets. So we will bump the references, but only for a moment, and then remove the file on the source, and we just leave with the destination. So we want this to always work, because this is just a temporary bump in the table. So for this, we can have like just
Extra
in-memory
table.
table,
yeah,
or something like that.
Yeah, I think that you could. I mean, the data structure you're talking about sounds like it has like maybe 3 words, like 3 8-byte words per entry.
Yes.
Like the DVA is 2 words, and then the ref count.
Ref count. Mm-hmm.
So 24 bytes.
Bits.
24 bytes, right? Total.
Oh, sorry. Yeah. Mm-hmm.
For the entry. So, you could do that. Yeah, you could probably say, yeah, it's got to all be in memory, or you could do the Bloom filter technique, and then instead of 24 bytes, it's like 1.5 bytes or something of keeping the Bloom filter. That would tell you if it's possible that it's in the table, but then you have issues of like, oh, I gotta like rebuild the Bloom filter every so often, and like it's definitely annoying. It's definitely like more work to manage that.
Another idea would be to maybe keep additional reference counters on the dataset structures to at least know that this dataset never used block reference table, so we don't. So free for them will be at least free, but
yeah. I mean,
yeah, like
I
think
would
we
probably
have something like that for some of the checksum and compression algorithms, right? Where we know
yeah.
if every
You tell if
block
some
that ever used
features
it
in
is done.
use in the
Yeah.
data set. I mean, I would probably go down the road of like just keep it all in memory, just because the performance win is like so much higher, and the use case for this, it seems like, well, so there's like the incidental kind of use case where it's like, oh, like I just want to copy this one file back, or like once a month or once a year I want to copy some files back, and they all have like big block size anyways, so you're just not gonna have many entries. And then the other use case is like, I want to clone some VMDK files, right? And I'm going to be cloning a lot of them. They're going to have like lots of random accesses and whatnot. And in the former case, it's like, well, it's so small, nothing really matters. In the latter case, performance could get very, very bad if it devolves into being the same as dedupe. And I think we'd be better off like saying, this is a new thing. It's the goal is performance is like a gajillion times better than dedupe, and the way that we get that is like we make you keep it all in memory, and then like the on disk format can be like a log or something like that, like the DDT log thing that was prototyped, and then we can make more kind of guarantees about the performance. Like you might not be able to BRT your thing if you don't have enough memory, but if you do, then the performance is going to be blazing fast. And if you don't like that, feel free to fall back on dedupe.
Mm-hmm.
For the freeze, could we break the table up like one table per VDEV or something, so that when you're freeing, you know the block pointer you're looking at, and you only have to look at the table that's for that VDEV or something?
That was my
Yeah,
idea.
but
Actually make the entries smaller
Yeah.
to keep separate tables per VDEV, so we don't really have to keep
Yeah.
VDEV ID in the entry.
So instead of 24 bytes, you're smushing it down to like maybe you can get to 12 bytes or something like that. I think that's a good idea. But it doesn't fundamentally change the problem. It just reduces the size of the entry. So like now your RAM is twice as effective or whatever. Because
Well, and it would limit the search space a bit. Like if you're looking for, is this block in the table? I don't have to search the 4 VDEVs that block is not on.
But the hard problem is the hard problem is like I'm RMing this file. The file has a billion blocks, and like they're spread out over the entire pool.
Yeah,
that's the problem that matters, I think. And if you're looking at it just with like one single block, then yeah, the performance of doing the one block doesn't matter at all.
Right.
It's when you're doing a gajillion of them, and they're likely spread out over everywhere on the whole pool.
I guess that raises the other questions. Does it make more sense to try to group them by like birth time or something? Or is there a certain ordering or structure we could use that would mean that more of the time we would have to search less of the space? But everybody's use cases or usage pattern is different. So I don't know that, you would be able to say that, this big file I'm going to delete, most of its blocks are going to have a birth time close together necessarily.
Yeah,
Because, like you said, a VMDK is probably going to have basically effectively random birth time. Every block's going to be a different time.
Yeah, and I think that that's the use case that makes this project kind of worthwhile, or like most valuable is the VMDK cloning case. The other cases are just much simpler and could be handled with more kind of tricks. Versus you can't do those corner cases of like, oh, I just want to copy a file from a snapshot, or I just want to copy a file. I want to move a file from one file system to another, and there's no snapshots involved. Those are like, you can get by with even less cost than the block reference table, because those are special cases.
But it does sound like the block reference table worked nice for my idea for the kind of a rebasable clone, where you basically have an overlay file system, and then if you modify a file that doesn't exist, or if you access a file that doesn't exist in the overlay, it goes to the underlying file system and finds the file. But if you modify it, we have to copy up the file to the higher layer. And if we can use BRT to do that, then we get the kind of clone type semantics where you're not, just because you change one block in this giant VMDK doesn't mean that the new file system needs to contain the entire VMDK, or doesn't have to reference the entire, or has to reference it but not show up as a use.
Doesn't have to copy it. Yeah.
Yeah.
I'm wondering if there's a mode of this where, as the table starts to get larger, that instead of just being like, okay, I can't clone a file, it's like I create entries that are temporary. So just so that I get the performance win of doing the clone, but eventually, like I'm actually going to copy and overwrite the blocks. Like I'm going to create a new file under the covers, but outside of the performance path. So that you might be able to get like a performance win for copying like large files around. But if you don't have enough memory to be able to hold the entire table, eventually you're like, I'm not going to keep it in there. It's just going to be temporary, or like there, maybe the last 10% of like, once I get to that point, it's like I'm going to stick files in here, and kind of in the background, I'm going to copy in the performance path. I give you a reference, but that reference is going to go away, so my table never gets big enough. Instead of just being like, I can't do this.
Yeah, like doing something like maybe like kind of reserving some of your table space for these type of operations, where it's like, okay, I'm dedicating a gig of RAM to this, but an eighth of a gig is reserved for these like allegedly temporary uses. And if you're like MVing a file between file systems and there's no snapshots, then you could say like, oh, like I would like to add stuff to BRT, but I have a special flag that says that I'm going to use the reserved space because I'm going to be freeing it soon.
Right.
Yeah.
But in the background, you still do copy, right? So it's from the user point of view, it's hard to predict if you will need additional
If you'll
space.
use the space or not.
Yes. Yeah, true. But it versus the other cases, like I only have so much memory. So at some point in time, I'm going to have to like do copies anyway.
Yeah. I mean, I would probably expose this to userland. Like you need some fancy copy utility, right? To
Right,
do
where
this.
I think Pavel said he's got a new syscall, maybe it has a flag to say, you know, if you can't do it, devolve to the copy case, or if you can't do it, tell me, and I'll tell the user that,
Yeah.
you know, they need to free up memory in the table or whatever.
I think it's not. The system call is not the place to do the copy. I think we should just
Userland, make
return
userland
an
do it.
error. Yes.
Yeah, I agree.
Simply the same with if the source file is dirty or is being modified, we also return an error, and the application should deal with this.
Yeah.
Other way.
Exactly. So like you run ZFS CP, blah blah blah, and then it tries to do this, and if it fails, then then the userland will fall back on, running bin CP or whatever.
Then I have a chance to put a flag to CP or something that if it fails,
Force it.
fail, right?
Yeah,
or
yeah.
If it doesn't, just do copy.
Yep.
Exactly.
Yes. So, but also when we move a file between data sets, that also it might be hard to figure out, because if the source data set have snapshots, then we won't be able to remove the reference from the table. So
I think you would just say like, normally, I wouldn't worry too much about the running out of memory and having like a reserved or a super reserved space or whatever. I mean, I would just say, yeah, like you have this much memory, we're going to do our best at it, and then ideally add some observability tools so people can see like what, how much of your memory is being used. Oh, you're at 99%. Maybe you want to, be aware of that. Maybe add some tools that would let them like find which files are the ones that are, referencing things in the BRT. That are like kind of holding the references that are recorded in the BRT.
Mm-hmm.
Maybe even have like some kind of log where it's like, oh, because to do that, like for real, you'd have to go like iterate over all the metadata in the whole storage pool. But maybe you have something where it's like, here's a list of all of the data sets and object IDs that I've ever participated in the BRT. You have a log of that somewhere. And so then when you want to go like get status, you have this list of files, and then you can go just check those ones.
Mm-hmm. Yes, I was also that was also one idea I was considering, to use to store somewhere information about the source file. That could help us with the free case as well, if we could remember somewhere, because we cannot change source block pointers, but maybe we could remember the object ID somewhere.
I mean, I would, the way that I would probably approach this is like, we're trying to get most of the benefit most of the time, not to make it like completely airtight, and to make it perform really well, so that people could use it. People could think of it as like, hey, if I'm willing to devote some amount of RAM to this, then I can get like a decent performance boost of these kind of operations, and not have to worry about it tanking anything else. So I would design it more around like, yeah, every free is gonna go check in this, but it's all in memory, and I'm gonna make the hash table, like it's a big giant in-memory hash table. I'm gonna make that hash table really fast. Maybe you do like super optimizations to make it, super compact so that you get really good memory efficiency, and you kind of structure that hash table in some optimal way to get really good performance, as long as it gets in the hash table. And then if you can't put it in the hash table, then it's fine. We'll fall back on copying that block.
Yeah, with trying to keep structures like this in memory, I always wonder if what if you want to import this pool on a system that has less memory and you cannot really fit this into memory? We would probably need some kind of like, okay, we will make it work, but it will be slow.
Yeah. What did I do? I think with the dedupe, with the DDT log, I had the same problem. I think the issue is, I think what I fell back on was like, obviously you wouldn't add anything to the table, and you could log decrements. But then you have the problem of like, you need to look up to even know if you should decrement it. So you don't want to have to fall back on like log every free, which makes it kind of, which does make this a little challenging.
Because in essence, the BRT table could be treated as like, I know, space maps or something like that, that we basically just touching in the syncing context and updating there. But
because they're indexed on the DVA, does something kind of like the space map or metaslab make sense, where we have a limited size for each one, the amount of space it can cover or whatever. And I don't know that we'd have to load and unload them quite the same, but by limiting the size of each one, it would mean, while we would expect to have all of them loaded in memory, it's more tractable in the case where you don't have that much memory to only have the ones you're actually servicing loaded.
Yeah, potentially it would just, it could become very difficult, because it's like, the problem is every free needs to check, am I in the BRT or not?
Right, but in most cases, if we're going to have all of these BRTs loaded in memory, then having
fine,
it as 200 separate ones instead of one is probably not
right.
a big deal.
But if the problem is if you can't keep them, he's asking you, what if you can't keep them all loaded in memory?
Right, but if you have 200 separate ones, it's easier to keep the one you need to do. You can shuffle them in and out at least a little better than one big table that couldn't possibly fit.
It's theoretically possible.
Yeah,
performance
but
might
is it
be
worth the
extremely awful.
Yeah,
right. Like because you could be like, oh great, I'm in one TXG. I've decided that I'm freeing this million, these million blocks. They're spread out over the entire pool. They might or may not be in the BRT. Like probably 99% of them are not in the BRT. But I need to go do the lookup. So, like maybe I can only cache 10 out of my 100 BRT tables. And so, you end up being like every free. I mean, I guess what would you do? I guess you could be kind of smart about it, right? You could be like, okay, I have a list of all the frees. I sort them. Then I'm like, all right, these ones are in the first table. Load that table. Do the manipulations of it. Write it back out. Unload it. So basically every TXG, you might be loading, rewriting, and unloading the entire BRT, chunk by chunk.
Yeah, it's just chunks might make it more tractable than one giant list. Yeah. But I don't know if it's worth all the extra work that would probably be.
Yeah, I mean, you can do it with one table by just you're iterating over it multiple times, right? The advantage, I mean, you can do that, but you're only keeping, like, you iterate over the whole thing, but you're only building an in-memory table of, a third of it, because that's what you can fit.
Right.
And then writing that out, and then read the whole thing again, build the next third, etc.
This loading on demand is also nice, because if you even if you have like giant BRT table, but on some data sets that you but on the other hand, you're always freeing, so probably need to load it anyway.
This is where the maybe what you do is this. Maybe this is where you use a Bloom filter, where you say, like, look, if you don't have enough memory to load the whole thing, I'll read the whole thing, generate it in memory Bloom filter. Hopefully you have enough memory for that. I mean, I guess you do. It's just going to be like less you'll get more false positives, right? Because the Bloom filter can be of some constant size, and then you look up all the frees in the Bloom filter, and if they say that, hopefully most of them say, nope, I'm definitely not in the BRT, and so you don't have to do anything. And then the ones that say maybe I'm in the BRT, you just log them and say like, yeah, that space is kind of leaked until you can load this on a machine with more RAM. I mean, you're going to be in a very degraded mode. It's just a question of how do you want to take that degradation? It's either like performance of all writes is extremely awful, or your space, like we can't reclaim some of your space until you load it on a bigger pool. I mean, I feel like the latter is more palatable.
I don't really like the idea just that we log and leak space until we import the pool on a bigger system, because that may never happen, and because maybe you just took the memory out and it's not coming back.
I mean, I feel like the system administrator can make smart choices. Like,
yes, we would definitely need to like let him know that this is the reason the performance sucks.
Mm-hmm.
Yeah. I mean, the alternative of saying that, yeah, you can do everything, but the performance is like 1,000 times worse, 1,000,000 times worse. I don't know, to process your frees, versus being like, yeah, like we can process pretty much all the frees of things that are not related to the BRT. And the BRT things, like you don't have enough memory for the BRT, so like we're not going to do those frees right now.
Yeah.
Yeah, I feel like we probably would want to do like we did for device removal, have a line in zpool status telling you how much memory the BRT is using.
Yeah, for sure.
Okay.
And it should probably be configured, right? Like there's some zpool property that's like, use this much RAM for the BRT.
Yeah, BRT quota or whatever.
Okay, guys, I took 40 minutes out of our, so I'm not sure if there is time for demo, but thank you very much.
I think this is really cool. Why don't we cover the remaining agenda items, and then if there's time, come back for the demo.
Yeah, good plan. Thank you.
That's super easy. Here's 2 reviews that are ready for review. I saw, Matt, you looked at the VDEV one yesterday. I have to go through that. But the Linux namespace one, I think all the outstanding issues are covered, and hopefully that can land soon. I think the only open question is, what if the namespace goes away and ZFS is still referencing it? It doesn't cause a problem for ZFS, but it means if the namespace, if everything that was running in the namespace closes, the namespace goes away. And if somebody created a different namespace and it happened to get the same pointer from the kernel or whatever, then that data set is now with this potentially unrelated namespace, and it can be viewed from inside there. I don't know if there's anything ZFS can do about it, because the Linux kernel doesn't seem to have a way to tell you that this namespace is going away or whatever. But besides that, it looks ready to go. And then VDEV properties, I just have to look at Matt's feedback from yesterday.
Cool.
That's all I had.
All right. Other questions or topics?
Quickly, since I didn't make it to the last meeting and one before that, I was on vacation with, there's that issue with the encrypted ZFS with the dnode hashes, where with Mac OS on a Lumos, there was an incompatible format change that happened during the ZFS encryptions thing. So anyone running a intermediate OpenZFS could potentially hit this as well, because there was that incompatible format change. I think I finally have come up with a solution, and I can maybe just hash out the details on a Slack. But the problem is that there's the user group and project D node, and the bug is that the project D node wasn't included originally, and when Mac OS and Illumos took it over, we didn't see that until after it got we got released before that bug was there. So now we have encrypted data sets in the wild that don't include that hash, which then makes it impossible to exchange encrypted data sets between the two. My thought is that there's the obset fizz-t has quite a few free bits in the flags field. There's only 3 being used out of 64, and so I was thinking you could do 2. Kind of the idea is one to say if it's been quote unquote upgraded, and the other one to indicate the state of what's there, so that if it's 0, it's kind of okay, try both. And so that like kind of what happens today on both platforms is the same, but then after upgrading, then the other bit indicates the state. So that way an operator can, they can switch it at their convenience versus, oh, I import it and I've changed all this and now I can't, oh, you want to go, go back. Well, too bad, you want to try to avoid that. And so that was the kind of the thought about that, is kind of use that same upgrade mechanism to just, basically then use the bit to set what it is. So that way then both sides, when they see that, can just consult the, flag to know what it should be, as well as be able to change it through like a property. And then, oops, sorry, I hit my, move my,
We can still hear you.
there. Okay, yeah, because it went over to the hot corner and it started to lock it, but the screen. But and then so that way, then you could set a property that would change which one it's used. Is kind of the basic idea, just so that way, kind of the current state on existing things would be the same, but then anyone with the fixes on either side, they'd get the upgrade, which would then just say, okay, that other bit tells which way it is and kind of reflects the property with how it is today without changing it. And then they could, go in and change it whenever they want. And so I just haven't had time to finish coding it up, but that was my thought on that. I don't know if anyone has, if there's dragons there or.
I think that what you described, I think I understand it, and that sounds great. I mean, that sounds like a really good, full, robust solution. In my opinion, I would probably be fine with a much simpler approach of just saying like, we try both checksums forever, and like there's you don't need any feature flag, you don't need any whatever. Just we accept both of them forever. Like I think the security implications of that are essentially 0.
Yeah, but it's on the right side where it gets a little hairier, because it's like, okay, because what do you, which one do you do on the right side then? Because if you're worried about, compatibility with whatever your previous is, that's where it gets a little messy. That's what I was thinking with.
I guess that's true.
Yeah, and that's where it gets a little more, because I know there's actually, someone that actually has quite a few data sets impacted by this. And so, that's why
I definitely support going, doing the full solution too. If you have time for that, that would be great.
Yeah, because I did quote just a simple, oh, we just accept both and then write out the new one, and that works. I tried that works fine, but then it's just the whole. Now all of a sudden, now if you want to,
the ones that use the wrong one, now you can't downgrade.
Yeah. So, but. Yeah,
so you could do like, we keep writing it out the way we used to always, but that's like not great either.
Yeah, and so that's why I was thinking, well, we could just have a property, that reflects that, and that we, when we do the quote unquote upgrade, it gets set on the first, to reflect what it is, and so that way, like I said, on an older thing, they'll just see, they'll just ignore those bits and they'll just do what they do today, which mean, so what works today, would still work with that, but then like I said, if you, so then So then the operator can just, if they want to choose one way or the other, then they have that control and the expectation, so they're not surprised. So, okay, if like I said, if there's no obvious flaws or foot guns in that approach, I'll continue on it. But I just wanted to ask, since like I said, it impacts, like I said, not just Illumos, but Mac OS as well. So that way and then like I said, then everyone else will be able to, get it everywhere. So then everyone will be able to interoperate on those. So.
Sounds good to me. Anyone else have thoughts on that? All right. Paul, do you think you have a 5-minute demo, or is it going to take longer?
It should be more than enough.
Okay.
If I will be able to share my screen. Okay. Can you guys see my
I can
terminal?
see it, yeah.
Okay. So I have a pool. The feature flag is already there. It's an early build, so BRT is not in use yet. I have a single file, 4 GB file on the pool. So that's the file. So I would like, it's of course virtual machine, etc. But I'd like to show you the difference and the performance difference we may expect by using BRT. So I will just do regular copy of the file, export the pool to make sure everything is sync. It should take around 20 seconds or 30. Hopefully not more.
The zpool sync command should work as well instead of an export though, right?
Maybe.
Yeah, but that's probably not the slow part.
Yeah.
Okay. And now so we have 8 gig used now. And let's try to clone the file. Yeah.
Boom.
So like an order of magnitude quicker, at least. And of course, there is much less I/O as you would expect. So yeah. So I think that's one of the huge benefits of this.
I assume you're still also just referring to 8 gig still?
Yes. So sorry. Reference. Actually, what does it refer? 12 gig.
Does it know about that? Like, how are you doing the accounting?
Yeah, that's a good question.
Because it's kind of like the dedupe table. It's in that it's global to the pool. You may not be able to save this, show it on a per file or per data set.
It's weird because
basis.
I was sure it did work. At least the reference was not increased, but that's weird. But the difference I saw between this and dedupe was that available space is decreasing. In case of dedupe, it doesn't decrease properly.
Yeah. Well, here, I mean, what dedupe does is correct, right? Well, a couple of things. First, let's talk about the refer. I think that the way that you're doing the refer space is the way it has to be done, because imagine like if I have 2 file systems and you do the copy and then I do the copy into a different file system. So now there's 3 references. Now I'm going to delete some of them. Depending on what order I delete them, I might need to change the space referenced by a different file system, right? Like if you're saying when I make the copy, it doesn't increase the refer, then like I make the copy, it doesn't increase the refer. Now I make the copy to another file system that presumably also doesn't increase the refer of that file system. Then I delete
The
like
original.
Source.
the originals. Now nobody's referring to that space.
Yeah.
Yes, you're right. I think I'm.
So you have to handle the same way as dedupe, where like everybody gets charged because we don't know when to uncharge people, and you don't want to have this like
Surprise.
surprise where it's like I change my file system and then you suddenly get charged more. So instead we just charge everybody the full cost all the time, and then there's like extra magical free space. So dedupe has some, I forget how it works, but like something that makes it seem like there's more space. And you would want to do something similar so that the avail doesn't go down the way it is now. Like if you look at zpool list, then you should, there you did it, right? So zpool list only has the 8 gig allocated. It's just now you have a bunch of free space that can't be used by the DMU, which is why you need to do this like hack up the avail space. And you can look at how dedupe does that. You want to do basically the same thing, I think. And there's some weird, like, it has some weird interactions. I think there's bugs filed for like, it has some weird interactions with like quotas and reservations and other things, but it works well enough.
Yeah, there is some logic I still don't understand about dedupe. There is some repair mechanism that I'm not sure how it interacts with scrub and resilver. Why is it there? Also, there is some logic related to not needing to scrub blocks multiple times if they're referenced multiple times. So
yeah, that might be a lot harder to do for this. I think you would have to have some auxiliary data, like having some bit in the BRT or some other table that tells you hasn't been scrubbed yet. Because like with dedupe, the scrub is done via the DDT, right? So the DDT has all the info. So it's like, well, we just iterate over the DDT, scrub everything in there. And then when you're iterating over the indirect blocks, skip anything that has the dedupe bit set.
I see.
But you can't really do that here because even if you did, like you could check if it's in the BRT, but then if it is in the BRT, do you scrub it or not? You want to you need to scrub it if if this is the first one, but not scrub it if it's the subsequent one, and you wouldn't know whether there's no way to really know that without additional information.
But yeah, we could.
If you have the DDT,
have a bit,
if you have the BRT all in RAM all the time, then it'd be easy to just have like an additional bit in there that you start in the scrub, clear the bit, then set the bit. If you've already scrubbed it, that'd be pretty straightforward.
Mm-hmm. Yeah.
All right. Well, this is really cool. And I'm always excited about things that make dedupe less necessary. And it gives me hope that one day we can like deprecate dedupe in favor of something that has slightly less, well, that has massively less horrible performance. But that's probably a long way off. But I can still hope. I can still hope. So next meeting, the next meeting falls on the Dev Summit days. It's exactly 4 weeks from now. So I was going to propose that we cancel the next meeting, and so we'll meet 8 weeks from now. Any thoughts on that? All right, so the next meeting will be December 7th, and the earlier time 9 a.m. So we'll just skip this one, the November one. The conference is coming up, 4 weeks, right? So I don't know about you guys, we are busy preparing talks. Look forward to seeing you all there. For the hackathon, I really like the idea that was raised, I think it was the last meeting by Alan, about trying to focus on bugs. if you have any like favorite bugs that you would like to work on or like to see fixed, let's try to collect those. There is a spreadsheet that I will send out an email soon or something. That to track proposed projects for the hackathon. And we can put the bugs that we want to address in there. The other thing was just like finding those bugs. Like there's a huge backlog of bugs. So I think it'd be super helpful. Oh, thanks, Alan, for putting in the link. It would be super helpful to go over the backlog of bugs. And even if we aren't like fixing them or anything, I think that the big benefit we could get from that is find the bugs that are really, really critical so that they don't fall through the cracks. Because I think that may have happened in some cases. So obviously it'd be nice to like close out issues that are no longer like actual bugs, investigate stuff. But those are all kind of nice to haves. The real big thing is like, hey, let's improve the quality of the software by making sure that we find and fix those really critical bugs that are, data corruption or panics that can happen easily. Because I know we don't have much of a process for identifying those normally, but I think it would be really helpful to do that as part of the hackathon. So maybe we can figure out how to divide the bug list into, a bunch of sublists, and then each person or small team could go tackle one of those sublists. Cool. All right, then I hope to see you all in 4 weeks. Please register for the conference. The link is on the OpenZFS website. Register for the conference so that you can join the Zoom and participate in Q&A. And we will see you all in 4 weeks. Bye.
Thank you, guys. Bye.
Thanks.